The working principle and applications of the 555 timer. The 555 chip is an integrated circuit chip. It is commonly used as a timer, pulse generator, and in some oscillator circuits. It can also be used as a delay device or a trigger, or as a comparator component, depending on the brand. The prefixes may differ slightly, such as NE 555, 517, LM 555, SA 555, and so on. The internal structure is similar. Their functions are exactly the same. Let's briefly talk about its internal working principle. This is its schematic diagram. Internally, it consists of a voltage divider circuit, voltage comparators, an RS trigger, NOT gate circuit, transistors, and so on. Why is it called the 555? Because inside its voltage divider circuit, there are 3 5K resistors and 2 voltage comparators. The C1 and C2 line is at 2/3 of the supply voltage, and this line is connected to the threshold pin. This line is at 1/3 of the supply voltage. This one is connected to the trigger pin, and the upper comparator is in the inverting configuration. The output is notably high. After a comprehensive series of intricate logical operations, a distinct low-level signal is subsequently output. This particular line also effectively utilizes both high and low electrical levels to precisely control whether the transistor is actively conducting. If it successfully conducts, then pin 7 will promptly discharge its accumulated charge to the ground connection. Conversely, if it is completely cut off, it will then present a significantly high impedance state. Let's briefly and thoroughly go over the essential functions of its various pins. Specifically, pin 1 is designated as the primary ground connection. Pin 8 is the power supply, and pin 3 is the output pin. It can output either a high level or a low level. Pin 4 is the reset pin, which acts like a switch. When it is at a high level, this timer will work. If it is at a low level, the output will always be low, and the entire chip will not function. Pin 7 is the discharge pin, which is used to discharge the capacitor in practical circuit applications. Pin 5 is the control pin. It controls the threshold voltage of the chip. When this pin is left floating, the default is the expected voltages are 1/3 and 2/3 of the supply voltage. Pin 2 is the trigger pin. When the voltage at this pin drops below 1/3 of the supply voltage, pin 3 can output a high level. Pin 6 is the threshold pin. When its voltage exceeds 2/3 of the supply voltage, pin 3 will then output a low level. When pin 3 is at a high level, pin 7 is in a high impedance state. When pin 3 is at a very low electrical level, pin 7 is actively conducting, and at this particular time, it effectively discharges its accumulated charge to the ground connection. Now let's carefully take a detailed look at this fascinating dual flash lamp circuit and thoroughly analyze its complete working process. The electrical power supply initially enters here, then passes through the resistors R1 and R2, subsequently charging the capacitor C1. The positive terminal of the capacitor C1 is directly connected to both pins 2 and 6. At the very beginning, the voltage across this capacitor is very low. When it is below 2 volts, it meets the trigger condition for pin 2 and outputs a high level. This place is also at a high level, so both ends are at a high level and the lamp does not light up. This place is at a high level. This side is connected to ground, so this lamp lights up. As the power supply continues to charge the capacitor, its voltage, when it rises to 2/3 of the supply voltage, it meets the threshold for pin 6. Pin 3 outputs a low level. This side is low and this side is high. This lamp lights up and that lamp does not. At this point, pin 7 starts discharging to ground, causing the voltage across the capacitor to dropping to below 2 volts. Then the previous process starts repeating again.